get a feeling for, what we currently believe, which is that what we're trying to do may not be compatible with KubeVirt. And I'm just trying to get confirmation that whether or not that's the case. So we have a use case where we're trying to not just create a VM and stop and start it, but we actually have pairs of VMs. And as far as I can tell, it looks like it probably doesn't work that well within the controller for KubeVirt. And before we went off and do something different, I just kind of wanted to present it as an idea, like whether there's any way it would work within KubeVirt or we could expand KubeVirt.
Can I ask a question? So you're talking about pairs of VMs. Do you need these VMs to exist in the same pod? Or is this something where they can do they have to exist in the same pod or same host? What are the requirements when you're talking about pairs of VMs?
Sure. No, they actually have to exist in two separate nodes. So they're paired, they're pairs of nodes, really, with a pod in each. And that is what allows us to do a very fast failover from one to the other. So that's why they're in a paired configuration, but they're failing over within 1/10 of a second because they directly know about each other.
So your main issue here is probably then on how to direct the traffic from, for instance, ingress through services to the right VM. Is that the thing?
Well, we actually do that. We take care of the networking ourselves, within the two VMs by the way that we configure the ARP going out to the switches. So we have a solution for that. It's more we're trying to control them from Kubernetes, the Kubernetes API, and that's where we're trying to use KubeVirt to also like start and stop them, but as pairs. Is that clearer?
Okay, so just creating two YAMLs or deleting two YAMLs or modifying two YAMLs in a row is not good enough, or is that what you're saying? Or
well, it's more how it then shows up and the way you would control the pair. So if it's under KubeVirt, it's just these two separate VMs, and there's no notion of a pair.
It's kind of like a stateful set of two. You manage the stateful set instead of each individual.
Yeah, it's exactly right. The closest thing is a stateful set of two, but it's a paired stateful set, which is even slightly different than a stateful set. Yes, it's very close to that.
So are you guys willing to create a controller yourself that's built on top of KubeVirt? Like, would that be an option?
Yes, I'm the architect and we have a whole team. So we have whatever I figure out the team to do, we can do. So yes, anything is possible.
We had, I think it's 18 months ago, a thought experiment or proof of concept, something called VMCTL, and it is in the KubeVirt repos. It hasn't been maintained for a bit, but the notion there was to be able to create multiple coordinated virtual machines at once. Now, it was not a controller in that case, if I recall. So it does not meet your needs. But I think the trouble there was that if we had a template virtual machine, but if it was deleted, there was no association between the children, the instances that were then spawned. So you could get in weird states where things were hanging around that should have been deleted. And that's just due to the nature of the fact that we were just using resources to coordinate with each other.
So,
go on.
Regarding diversity, David has a more advanced experiment going on regarding to that, where you could use a stateful set or deployment natively from Kubernetes, and it would spawn the VMs for you. Still, what I'm not entirely sure is when I think what Daniel just said is, it's not exactly like a stateful set, for instance, right? So it's, when I understood you correct, Daniel, you would kind of expect that, for instance, in a stateful set, you have the behavior if you roll out 2 and the first one has an issue or whatever, or you scale it up to 3 and there's an issue, it just doesn't do it anymore. It just waits until this is resolved.
Yeah.
And that's probably not what you want. You want it to be more available, not less in this case.
Yeah, or it would spawn another one in its place. If you have a stateful set of 2 and one goes down, it's going to reproduce the second one, right?
Yeah.
Um,
I guess it also depends on which node failure behavior you want to have. Like,
yes.
Yeah.
Yeah. I mean, there's a lot. It's close to a state. It's very close to a stateful set of 2. It's very close to that, and we could probably work with that construct of a stateful set of 2. And we would be willing to do a controller. I mean, we're gonna go in that direction, probably, is kind of where we're headed. And so I just kind of wanted to raise it and just see if that was the right solution.
so I guess yeah, David, go on.
I don't know. So there's 2 approaches that I see with this. There's a layered controller that you all build on top of our constructs, like our APIs, that allow you to manage a single object that underneath it manages 2 virtual machines, however you want to do it. And then the other approach is to something we're experimenting with right now, and that's to be able to reuse the pod controllers, workload controllers for virtual machines. So that path would be using a stateful set directly and having that manage the virtual machines for you. And neither of those things exist today, but they're both options for you. If you were interested and you found that the stateful set of 2 idea seemed to work for you, that would kind of be a pilot use case for us actually implementing that logic. So part of the reason we haven't moved forward with the pod workload controllers managing virtual machines is it was unclear exactly. People have come to us and asked for things like that, but they haven't given us like a concrete example of, hey, we want to do this and we'll pilot this. Would that make sense, or would you want to go off and investigate if that would make sense for you all?
Sure, I would certainly take it as an action to. That's what I'm in the process of really doing, is looking at what we should do at this point, and I have to respond to management pretty quick on a solution. So yes, we are actively engaged, and we're adding engineers to this project. So yes, we will look at pod workload controller under KubeVirt as one path, and the other one would be really adding a controller to Kubernetes that would just be kind of like a CRD extension, a separate controller, an operator. So yes, I'd be interested in talking further offline on what you're doing, David.
Am I still on mute? No, I'm not. Okay. I'm going to post somebody already posted the chat. Oh, is that the same one? Yeah. So that's the PR. I just posted it again. Maybe if you're interested in looking at that idea of a pod workload controller, take a look at what I've done in the PR and kind of the discussion there, and investigate whether that's something that makes sense for you all. We can catch up offline about it.
Okay, great. Sounds great. Thank you.
Yeah, great topic.
Sorry, typing on mute, trying to catch up. So I think that pretty much puts that topic to bed, unless there's any thoughts or questions. All right, next subject, turning it over to Jed to mention SE Linux.
Hi, yeah, can you hear me? Yeah, I just wanted to briefly mention that the 117 lane is now mandatory to pass for PRs to get merged. That lane has SE Linux enforced. So if you have a test that keeps failing on your PR on that specific lane, it's probably SE Linux. So I would recommend looking at the artifacts to figure out what are the denials and try to fix them. I'm obviously always available if anybody's struggling, because SE Linux can be a pain.
I don't think it's fair for you to say that it's always going to be SE Linux's fault. But I would agree that if it were something new and unseen, that might be somewhere to look.
Well, so if the other lanes all pass and the 117 lane keeps failing on the same test, I would say there's a pretty good chance that it's SE Linux.
Fair in that sense, yes. All right, any comments or questions on that? Is there anything else that we'd like to raise today?
And sorry, also 118 is coming, and it seems to be based on 117, so it's also going to have SE Linux enforced.
Oh, that's a good point. From now on, we probably will leave SE Linux enforced on their new lanes, just so that we're compliant with that.
Definitely. Yeah.
Okay, is there any other topics that we want to discuss?
Hey, this is Fabian from Red Hat.
Hi.
The Eurovision Song Contest took place 2 weeks ago. It was really boring, but despite that, I have a question. Li Yao from Intel, I wonder if your audio is better today. Oh, hello, cool. So I wondered, just because I saw you, I wondered if you wanted to
My network is not stable, so maybe, yeah.
Ah, okay. Then we continue on the PR, I guess, to discuss it there.
Yeah.
Okay. Okay, I think then we continue the discussion on the PR, if that's fine for you.
Yeah, so about the device plug PCI pass-through.
Sorry, could you repeat that, please?
Device plug-in PCI passer?
Ah, yes, exactly. Yeah, that is the topic, right? How to do the API for the QAT device you're coming up with, but to generalize it to support other devices as well.
I have updated the issue I have investigated in the PR page, and I found that different device plugin will set different container runtime environment value. So the function that the SRV device plugin used is not suitable for QAT, for IPJ, and for other device plugin.
Right. Yeah, that I think I saw your last comment on that one, right? That you laid out the 3 different ways of how we're doing it. Yeah, maybe it's best to continue it there on the PR.
So I think maybe we can create a field named environment value and set it by ourselves in the YAML field. Yeah.
So how would this environment variable get set? That wasn't clear.
Wait, let me think. Maybe I will update it in the web page because my network is not stable. I can't hear clearly. Yeah.
Okay, that will work for us. It's probably the best course.
Yeah.
All right. Is there any other topics today before we close?
Yeah, hi. So I was wondering about this PCI pass-through. So what kind of devices it will be able to support? Is it like when we think about storage devices, will it be like when we can we use the existing storage devices directly into the VM and the network devices? Is it like that?
I think the discussion right now is about PCI devices,
Mhm.
any PCI devices.
Any PCI device.
Obviously, we expect that the PCI device that needs to be passed through would have a device plugin that does the assignment of the device itself.
Yeah. So we have a use case. That's why I'm pitching in here. So the storage devices, we have a lot of block devices. So we would like to have a VM directly accessing or recognizing the storage disks and make use of writing the file systems or make FS kind of thing. So is that directly possible, or do we need to do anything in that case?
You can just use a local PV, right? So you can create a PV to give access to a block device on the node. I mean, how do you want to access the storage device using,
Yeah, we just want.
something else?
Yeah. Imagine this VM is a storage solution, and we have number of disks on the bare metal, and VM has to recognize DAV, SDA, SDB, SDCs kind of thing, and create file systems on that, MKFS, XFS, or something like that. So that is one of the use cases for us, and how to achieve such things? Is it possible directly?
So one easy way is to use the metadata in the VM. So, for example, each PV can be labeled with a serial number, and then in the VM you would recognize the storage using the serial number that you already pre-assigned ahead of time.
Mm-hmm.
Alternatively, you can tag it, and then on the API you would say that this specific volume, it has a tag, and we would provide the PCI address. The PCI address of the disk and the tag as a metadata, and then you could read this metadata and recognize the storage according to this PCI, the coupling of the PCI address to the tag.
PCI address, is it a UUID you are talking about, or?
Yeah, well, it can be UUID. Well, it's not UUID really. It's an address.
Okay.
Just a second. Let's look at the flow. I think the first step would be that you need to create a local PV on the nodes, which are exporting every block device that you want to make consumable by VM, right? And they are regular local PVs you have from you are using in Kubernetes as well, right? Because then you can expose that like that local device, def SDA, let's say, right? And I think what Vladik is then saying is that in the VM definition, you then consume that local PV, and there you assign a serial number to it, right? When you create the disk part, you assign a serial number. And then Vladik, please help me, how is that new mechanism you introduced called to then expose the volume information to the guest?
Yes, and then we're through a config disk or means like that. I can post a link to the documentation and how exactly does it work. But on the VM definition, we can provide a tag for a specific disk that we're passing to the VM. And then there's a known location on the VM that this metadata would be created. You could read this metadata. It's a device metadata. And it will provide you with a structure of a tag and an address on the VM. So then you could do LSPCI and find the device that you're looking for according to this address.
Yeah.
So to be clear, we're talking about writing a plugin, a device plugin that makes that association, right?
No, it's all done. I mean, you can do, the short answer is actually yes. You can take a local storage device and give it to a VM. And what Vladek is alluding to, how to identify the special device, right? Because if you're then inside the VM, you cannot differentiate which PV is which device. That is difficult. But we have the functionality, which is like the device role tagging, which was implemented to help you to correlate the tag you gave on the VM API to correlate that with the disk inside of the VM, right? So if you said on the outside, this is my disk A, disk B, disk C, then inside the VM, you don't have that information anymore. So inside the VM, you can then use the device role tagging and to see this device, def SDA, inside the VM is actually mapping to disk A.
Yeah, and the only thing that it's currently working with the Virtio disks, the disks that use Virtio as a bus, because these are identified as PCI devices then. With the SCSI, it's a little bit trickier, but there's another way. How these volumes are being passed through to the VM?
From what I understand, he was asking how to do that. So I don't know if you're going to get a definite answer.
Yeah, I'm asking how to do that. So the disks are SATA disks. So I'm not really sure how to do that. I'm figuring out how to achieve that.
Okay.
This might be a great opportunity to use the mailing list, just because instead of saying we can provide you that information, we can provide the information.
Yeah. I'll take care of that. Thank you.
Liao, you spoke up a second ago.
I found that when we get the device ID in the compute container, and it will it will use this device ID to the libvirt domain field through the host dev, and then it will assign the device to the VM. This is my this is what I have found. Yeah.
I think that helps you correlate. If you're looking at the compute container, the VM's already running, so that would be after the fact to see what was associated.
I have to do the test. I have do the test, and I found that in the computer container we can see the if we device SRV VM, we will see the PCI device inter and so on environment value, and if deploy a QAT, if create a QAT VM, I can see the prefix is QAT, and for GPU it will be something like GPU device plugin, and in the computer container environment value. Yeah, we can, I can see it, and yeah, how to say it? And in my I use a function named found by prefix, and use that environment value to find the device ID and give it to the libvirt domain field. Then the VM can get the device. This is what I do for the whole PCI pass-through workload. Yeah.
Got it. Okay, so that's back with the in reference to the PR itself. Okay, that makes more sense. Got it. All right. With that, are there any other things to raise on this topic? Okay. Once again, asking, are there any other topics we'd like to raise today? Okay. Well, thank you, everybody, and see you next week.
Thanks.
Thank you.
Bye.